shouldn't take terribly long. Oh, and then I forgot to update it. We're going to start on that next unit with probability. It's a fun unit. Mr. Anderson already looking at it because he's going to be teaching on Friday when one of my old professors and his current professor comes in to do an observation. Okay. Yeah. I have full confidence.
We will be
all right. Number 9. So this is from the progress check. I just want to make sure we know this. So a botanist created a linear model to predict plant height from soil acidity for a certain type of plant. The slope of the model was 2.5 centimeters per pH level. The standard deviation of the sample plant heights was 4 centimeters, and the standard deviation of the soil acidities was 1 pH level. What is the value of the correlation coefficient? Did we go over this one? I didn't think so. Okay. This one's a weird one. I haven't personally seen it on an AP exam question before because they've never had it on the free response, but I definitely could see them putting it on multiple choice. If you're looking at it and you're like, what the heck is going on here? I get it. One thing I would highly encourage you to do on a problem like this is I would label stuff. So for example, what is this 2.5 centimeters again?
The slope.
The slope, my B, right? The standard deviation of the sample of plant heights. I need a better marker. Yeah. You okay over there?
No. Did you say Gesundheit?
Yeah. Yeah, that means bless you. German, right? Yeah. So there's my slope. Standard deviation of the sample of plant heights. So that's a standard deviation. But which standard deviation is that? That's the standard deviation of y, right? We're predicting plant height from soil acidity. So explanatory and response. So standard deviation of y and standard deviation of the soil acidity, standard deviation of x. Is there anything, and then also we're looking for r. Is there anything that relates those 4 things?
The formula.
There is a formula, yes.
That B is equal to R at times S over Y over F over F.
Well, S sub x, right? Standard deviation of y, standard deviation of x. One thing I would highly encourage you to do is when you are reading these formulas, read what the thing actually is. Don't just read the letter, right? B is the slope. R is correlation. Standard deviation of y, standard deviation of x, right? So the slope is equal to the correlation times the standard deviation of y divided by the standard deviation of x. That is a formula. And again, that's a weird one. I haven't seen it show up a ton, but when you write out those letters, there's a formula for that, and we have a formula sheet. So take advantage of labeling stuff. Annotate. I'm sure if you've taken an AP English class, they had you annotate your passages, right? That's a huge part of AP English. At least it was when I took AP English ages ago. I assume it hasn't changed a ton. Annotate the question. By annotating the question, by labeling things, it's going to make your job easier. Right? So my slope was 2.5 equal to the R that I want times 4 divided by 1. See how straightforward that becomes when we do it that way? I think that's right. On top of my head?
Wow, that is correct.
Yeah.
Oh yeah.
Thanks. It's like I've taught stats before. There was that last progress check where I was like struggling with that one question. We won't talk about that though. But yeah, guys, please take advantage of labeling stuff. That is, so one of the big things that I'm seeing a struggle on progress checks with and with multiple choice on DYUs and tests is 1, annotating the question. Annotate it like an English question. 2, process of elimination. Like take advantage, and also showing work. Even though it's multiple choice, you still have 2.25 minutes per multiple choice question. Some questions will take no time whatsoever. Some will take longer. Take the time to annotate. It'll help you organize your thoughts, be analytical with what you have going on, and that will help you significantly, okay? So we've got to practice with those annotations, practice with showing work, because I can't see your work on progress check. I can't. But when I look at y'all's multiple choice questions on DYUs and tests, very few of us are showing the amount of work that I would even show on that question. And if I would show that work, you should probably show that work, right? Like, writing stuff out helps organize your thoughts. It helps focus your attention. That is a huge test-taking strategy, but just also assessments. Did someone have their hand up a second ago? Ian.
I was going to ask how many questions are on the AP exam?
40 multiple choice in an hour and a half, and then 6 free response in an hour and a half.
Wait, 6 individual ones or like 6 divided?
6 multi-part ones.
Jeez.
So we've had 2 free response questions on our test.
Times 3?
It would be, well, except one of them's an investigative task, and then 5 of them were kind of like that, but also
Tragic.
it's not really. Question 1 is always a univariate or bivariate data analysis question. Question 2 is always a study design question. Question 3 is always probability. 4 is some kind of inferential procedure. 5 is a mixed bag. 6 is, who knows, but usually pretty easy. No, there was no 7 in there. Star. All right. So number 11, Jordan is working on a business model for a sandwich shop. Based on past data, he developed this model where N hat represents the predicted number of turkey sandwiches sold in one day for a price of P dollars per sandwich. Which of the following is the best description of the slope of this model? This is a classic example where on free response I would show some work and multiple choice I would show some work. First things first, what is slope?
B over B.
Sorry, what is the slope in this one?
Oh, -3.
Okay, so slope is -3, but how do we calculate slope?
Y2 minus Y1. Oh, shoot, my bad.
So you can do y2 minus y1 divided by x2 minus x1, but that's a procedure that loses the meaning of slope. Like the meaning of slope is change in y divided by change in x, or rise divided by run. But this is the best way for AP stats. Okay? Remember also it's not going to be a change in y, it's going to be a change in y hat, right? It's only the predicted y's. -3 to what? Right? If we don't have a denominator, the denominator is understood to be a 1. Now throw your context in there. What's being predicted? So we are predicting number of turkeys, I won't say turkeys, turkey sandwiches sold, okay? What's the change in X?
What?
The change in price.
Oh.
Okay, now I can clearly see what's happening here. For every extra dollar in price, the number of turkey sandwiches sold
3 less.
is decreasing by 3. Notice again, labeling helps me focus my attention. Free response, multiple choice doesn't matter. If I'm asked to interpret slope, which a lot of us, when I'm looking at your Frere models, we're forgetting, when I ask you to interpret, or the AP exam asks you to interpret a least squares regression line, we are asking you to interpret the slope, the y-intercept, the correlation coefficient, things like that. So we got to learn how to do that. Yes, Ian?
So in this context, does the 150 represent like how many we sell without?
Well, if this is my slope, right? Then what's the 150 got to be?
The y-intercept.
The y-intercept. So again, label it, right?
Yeah, I was like asking like what does that mean in the context?
So 0 what? Zero, $0 price, right? So a $0 per sandwich. So if we're not charging for the sandwich, we predict to sell.
150.
Now is that realistic?
No.
No, right?
No.
The real world context does not always make sense when we interpret, but does that make sense?
Yeah.
But again, labeling it, right? And I should have said X and Y hat, right? So 0 sandwiches, and if you label it like that, those things make more sense. All right, so what's the correct answer?
C.
So it's each increase of $1 in the price of a sandwich. The number of sandwiches sold is predicted to decrease on average by 3. So you can, on the AP exam, I'm going to check to make sure this is right, but you can either say the number of sandwiches sold is predicted to decrease by 3, or the number of sandwiches sold decreases by 3 on average. Either one will be fine. So it typically decreases by 3, decreases by 3 on average, or is predicted to decrease by 3. All 3 of those are acceptable. Okay, questions about that interpretation of slope? We all engaging, let's say zoned in, but that's not it. Locked in? Leah, we locked in? Andrew locked in? Kenzie? We locked in? All right. Last one that we're going to look at from the progress check. Okay, researchers are investigating how the amount of monthly rainfall measured in centimeters affects the monthly growth in centimeters of a certain plant. From a sample of data, the researchers created a least squares regression line. Computer output is shown in the following table. Which of the following statements is an interpretation of the value 0.75 shown in the table? Once again, the first thing I'm going to do is label stuff, right?
Right,
Right.
right.
But when I look up here, I need us to pay attention to a couple things. First off, have we talked about DF yet?
No.
Then don't sweat it. Have we talked about SE yet?
No.
No.
T?
No.
Then don't sweat it. We'll talk about all those things eventually. But we haven't yet, okay? So I would write my equation. Now, remember an estimate, that's going to be the same thing as the coefficient. Okay? So I'm going to write this out. And even if you're like, I didn't see that, Mr. Kinney, 0.75 intercept, 0.15 rainfall, like those things should jump out at us as like, oh, we've seen those as coefficients. So what are we predicting? We are predicting the growth is equal to the coefficient of my y-intercept
Plus 0.15
times the rainfall. Notice I've labeled it, right? I'm asked specifically about this 0.75, so 0 is my x, my rainfall, and 0.75 is my predicted growth. I know I've done this for a while, so it's easier for me to move quickly through these things, but at the same time, if you had written these things out, would that have helped focus your attention so you're not struggling looking at answer choices? 100%, right? Like, writing this out with these things labeled helps make these things make sense. Notice we're not expecting increase, right? This isn't slope, but for a month with 0 centimeters of rainfall, the monthly growth is expected to be approximately 0.75 centimeters. Just trying to see, oh yeah. Yeah, V is backwards, right? Flip the explanatory in response. And when they say approximately 75% of the variability in monthly growth is due to its linear relationship with rainfall, what should that make us think of? R squared. Does it say anything about R squared up there? So noticing that language should trigger something, not in a bad way, but in saying, oh, I know that term. You guys, remember, I see, I'll get to you in a second, Madeline. When I talk about stats, you have to know the vocabulary and the concepts first, but then you have to apply them, right? And so make sure that you understand the language, the vocabulary there, master that first, but then also apply it as a practice piece. Madeline.
Why is the estimate so coefficient?
So the coefficient is, okay. So the reason why it's an estimate is when we say y hat equals a plus bx, those are actually statistics. Y, at the estimated y-intercept and the estimated slope, they are estimates of the parameters. So alpha would be the y-intercept for the entire population. The b would be the slope for the entire population of that plant. A and B are estimates of alpha and beta. That's why. That's a good question. Excellent. Yeah. So we'll talk more about why it's called an estimate in 3 units. In 3 units, yes. So we're going to do probability, which I am going to be nice about the probability unit. We're going to split into 2 to help focus our attention, make it a little bit easier on y'all. And then, because traditionally you do it as 1 big unit, we're going to do it as 2 units. And then we're going to do something called sampling distributions. And actually, we'll talk about it in sampling distributions, so 2 units. All right. And then, yeah. And Kinsey, you had a question, didn't you? Did you start to stretch or something? Your hand went up, didn't it? Just crazy? Cool. Awesome. All right, so I'm going to move through quickly through some of these. So here's the DYU, right? So ask questions as we go through things. But remember, an R being high does not mean it's linear. An R being close to 1 only is helpful if it's already linear.
Yes, I know.
Yes, but like, what's this residual plot tell me?
It's not a curve.
It's not that.
No, yeah, it is. I love you, Star, but I like you sticking by your guns, but no, that's a curve pattern. Okay, be careful about that, guys.
It's almost there.
The linear model is not appropriate because there is a clear pattern. You're not the only one who missed it, Star, but we need to recognize why it is E. Are there any of the other ones that we're now looking at where, like, Mr. Kinney, I could have seen it being this, or I'm confused why it's not this, whether you got it right or wrong? Kenzie, what you got?
Oh, sorry, sorry.
Different than number one?
Yeah.
Okay.
Wait, you talking about B?
Yeah. So linear model is appropriate because R is close to 1. Fun fact, well, just first of all, the R being close to 1 means it is a strong linear relationship, but is that actually linear?
No, I guess not.
Look at the residual plot though. You look at that residual plot and you look at this pattern, if there's a pattern in the residual plot, is it? No. Okay. So if we look at, and I don't think I ever showed this to y'all, but if you actually look at y equals x squared on like this scale, it's something dumb where, yeah, so like that's obviously quadratic, isn't it?
Yeah.
But if you actually check the r value from here to here, and it's even more from 0 to 1, that r is like a 0.95. But clearly, is that a line?
No.
No, it's quadratic, right? So you cannot just base it on what the r is. That's why you have to look at r, you have to look at r squared, you have to look at the residual plot, it has to hit all those things. Does that make sense?
Yes.
Okay. So just r does not tell you the complete story. Alright, number 2. For the most part, we were pretty good. But notice, like, if you ignore this data point, what happens to that set of data?
It'll tilt.
Then slope increases, y
So,
increases.
Yeah, notice this was the least squares regression line because this data point was way over here. If you get rid of that point, if you don't see it, that's all the data, right? You draw that in, what happens to my slope? It goes up, right? It goes from it goes a little negative to now fairly positive. What happened to my y-intercept?
Go down.
It goes down. What do you think happened to my r? I don't think it asked that, but what would have happened?
Super up.
It went up a lot, right? Like, right now, originally, it was nowhere close to those data points. But now, is it really close?
Yes.
Because this point would be called a what?
Outlier.
Not just an outlier. It'd be an influential observation. It'd be a
Horizontal.
potential outlier. And I would also call it a high leverage point.
Yes.
Because remember, high leverage means it's pretty far horizontally away. The only thing, and it would also have a large residual, right? So it's an outlier, okay? I would say that it is high leverage, and it is also influential. It heavily affects the line. Please notice, it can be more than one of those things at once, okay? It has a large residual, so it's an outlier. It's horizontally far away, so it's high leverage, and it definitely influences that line star.
I thought high leverage had to follow the regression line.
Nope, high leverage just means it's horizontally far away. Okay. High leverage just means it's horizontally far away. Now, if it's far away and it follows the regression line, if it had been this point, it wouldn't have changed the line at all, but it would have strengthened the correlation. So if it's in line with the previous data, it strengthens that correlation. Yes, Ian?
Okay, we messed up. I couldn't visualize what that line looks like with that point.
You couldn't draw a least squares, you couldn't draw a regression line through those data points?
No.
Like
No,
if you just ignore this, like
No.
if you take this point out, you wouldn't have thought it looks like this?
I was trying to do it with the dot.
No, they literally said to do what with that point? Remove that influential point.
Okay.
They gave you the least squares regression line with that point.
No, because I was trying to figure out what happened to the y-intercept and the slope. So I would be like, oh, this is originally with that point. Now remove it. But I didn't
Right,
know
so
how.
ignore it, just look at these. That's it, that's all
I
it
didn't
is.
know you could just do that.
Huh?
I didn't know you could just do that. But like, how would I know that the y-intercept would decrease?
Remember, so don't forget, a regression line just models the data. It needs to go roughly through the middle of the data, right? If that data point's gone, does that cut through the middle?
Yes.
Yeah, like notice that's not a least squares regression line, but it is a regression line. It is a decent model for those data points. So if you're drawing your own regression line, it just needs to approximate the data points. And when I compare this y-intercept to this y-intercept, didn't it go down? So like, Ian, this would have, I can't, so what's that number right there? No, it's
Which one? Oh, that's 120.
120 right here? And so it was this one, what, right here?
It's 170.
Wow. What is this one?
170.
170, what is this one?
180.
Okay, so it went from about 175 down to 160? If you go from 175 down to 160,
Decrease.
that's definitely a decrease, isn't
Seems
it?
like a decrease.
Okay, but like, how do you know it was
Almost
right?
forever.
It's a
What do you
positive
mean?
chance. Decrease in
This one or this one?
The first, the top one.
It's right, it is there. Like they gave us the regression line. Did you miss that this was y hat? That was the prediction regression line originally?
Yes.
Okay. Gotcha. Notice it tells you also shown is the least squares regression line. Who needs to read? Hey guys, I don't know if I've ever told y'all this before, but slow is smooth and smooth is fast. What I mean by that is, if you slow down and really pay attention to the details are going to give it to you. Like, if you are struggling with a question, which I've done this before, I talk about it when I do ACT prep. If I'm looking at it like, I have no clue what this question is asking, I'm going to slow down and reread it, because if you slow down, pay attention to the details, those details are going to tell you what to think about, which is going to make you faster overall. Because if I slow down and read the question originally faster, or slow down reading the question originally, then I'm not going to spend as much time on answering the question, because I'll know the details to pay attention to. Slow down, pay attention to the details. Slow is smooth, and smooth is fast. Okay? Are we good on number 2, or do we got any questions? By the way, you know that this DYU is yours. Even if you got it right, you can write some notes to help your thinking. Number 1, when I talk about that idea of, or in general, because then we went from the progress check, label stuff, like you can write that stuff down quickly. That would probably be a good idea for many of us. While I'm going over this, can you go ahead and pass out the fair model, next fair model, and then proficiency scales? Yeah. Not yet, but I'm just going ahead and prepping.
I'm coming because you're passing my basketball.
He's agreed.
But do you see, like, you see these 2 lines, right?
Yeah, but I don't get like, okay, so that horizontal line, that's with the outlier.
Yes.
Last line. But I don't get how removing that, I can't visualize how that's gonna change. How that's gonna make the line.
Actually, are they right there? Should be
Yeah, that makes sense.
That where would you draw a line to approximate the distance? Right there.
Is that
Yeah. Would it that line go through the data pretty well? That's it.
Okay, then how do the old line represent the outlier?
And that is the least squares regression line with that point included.
I like it.
Yeah. That is the least squares regression line with the old point included. All right. Number 3. Okay, I understand why a lot of us miss this one, so I want to break it down. I need to pay attention to this. This is the residual plot when we have length as the prediction, the input, the explanatory variable, and the weight is in pounds. So regression A is just length versus width. If I look at that, was length versus width a linear model?
No, wait. No, because it's a pattern.
There's a pattern. Bless you. And I think almost everybody picked regression B. Okay, so almost everybody picked regression B, saying B yields a better fit. We knew B yielded a better fit. Why?
Because
Because it's more
a
Because
pattern.
there's no clear path.
There's no clear pattern. It's more scattered.
But there's still a pattern.
Notice the question is there a linear relationship between X and Y or not? Well, here's X and Y. Is there a linear pattern between X and Y? Nope. What was there a linear pattern between? The log of length, is that what it says? And
Your log.
weight.
In inches, by the
The
way.
residual of weight. That's fine. But look, the original was non-linear. Right? The original was non-linear. So we had to go with this one that was linearized. And so I think almost everybody got it down to B was the better fit. Is that fair to say? But then it was down to B or E. Right. And so I talk about this all the time when it comes to ACT prep as well. Whenever there's a 2-part answer, only look at the halves. Look at the first half, and then look at the second half. Because like, when we look at it, and we say there is a linear relationship between x and y, or there is not a linear relationship, there's x and y, that is very clearly non-linear,
Not linear.
right? Between the x and the y. Or, again, you could have looked at regression B yields a better fit. Okay, so I've eliminated A, C, and D. Okay, just between x and y. So you got to be careful. Is it talking about the original data set, x and y, or is it talking about the transformed one? The original data was definitely not linear. Does that help clarify things? By the way, do notice it also has that equation up here. Y hat equals that. The common log of y hat. So that's what it should have been. Sorry.
Okay, so like if it had said there's a
So-
linear relationship between log and
Right. If it had said there was a linear relationship between x and the common log of y, that would have been correct. There was a non-linear relationship between x and y, a linear relationship between x and the common log of y. Okay, so be careful about those differences. Again, I feel like that's one of those places where some of us should probably be writing a note down about there's a non-linear relationship here between x and y, but there is a linear relationship between x and the common log of y. Kenzie?
Okay, this is probably a very dumb question, but like, how can you tell that it's not linear? Like,
So remember, this is a residual plot, right? With a residual plot, do we want it to be scattered or do we want a pattern?
scatter.
Okay, so the fact that there's a pattern tells me it was nonlinear.
Oh.
Does that make sense?
Yeah.
So, looking at the residual plot, the fact that there was a pattern here told me it was nonlinear. And the fact that there was no pattern told me it was linear. Okay? So yeah, good question. Again, the residual plot with a pattern, no good. Residual plot without a pattern, fantastic. I think, I could be wrong, but I feel like overall, for the most part, we were good here. Just in case am missing somebody, I'm just quickly point this out. Okay? Prediction, -6. And then it has to be 32, right? Because it's hundreds. Oh no, I'm thinking of the wrong one. Area of 74 square inches. Yeah. And then what do you have to do at the end of this?
you have to do the
Log.
square root.
Not a log. Square root. It was squared, so you just have to take the square root. Okay. I believe that the predicted squared was it 93, 535,
Yeah.
0.85? So all you do is you substitute into this equation, bring it down, take square root. That was it. Okay. Number 5. I think overall we were good on the variable. The explanatory was the role of the student. Now I'm going to talk through some of these a little bit more in detail because we got to recognize this idea about a mosaic plot versus segmented bar chart versus and also the different relative frequencies. We need to recognize the type of relative frequency. When I asked what proportion of the total sample had 5 or fewer absences, okay, what do I need to look at?
The X value.
I need to look at total sample, right? And I need to look at 5 or fewer. And by the way, I didn't give this to you, but if I were you, I would always find those totals in the margins. Take that extra second, right? What was this sum? 600, that's right. So 600 students, 100 teachers, 244,
406, 50.
400 and what?
406.
406,
Yeah.
and, nope, that is not a 6, and 50. Okay, for a total of 700. So when I say the total sample had 5 or fewer absences, where do I need to look? Am I looking on the inside or am I looking on the margins? I could look on the inside, but does it say teachers versus students? No, it just says a total of 5 or fewer absences. Aren't these all the people that had 5 or fewer?
Yeah.
No.
Oh, wait.
Well, yeah.
We're on number, I'll say we're on B.
Yes.
Yeah, okay? So the relative frequency, take the time to write it out. What is that, 650
over 7.
out of 700? Yes, you can just leave it like that. I think it simplified to 13/14
Yes. Oh,
or
yes.
0.92.
Yeah, 29.
Yeah, so do we understand how to get that one right, hopefully? That stuff will be on your test. Yes, Phoebe?
Okay, I know you said this once before, but I forgot. When they ask for proportions, do you give them the fraction or the percentage?
You don't give them percentage, fraction or decimal.
Okay.
At the same time, I don't think they'll count it against you if you do a percentage, but percentage is percentage. Proportion is a ratio or a decimal. Yes, Raina?
Yeah, I
And
was
then
good
Andrew.
on everything else, but I just missed like D and E parts, so
We'll get there. Stay calm.
just
Andrew? You do not. Good question. You do not. I will remind you these calculators though, if you just type that fraction in, it will automatically simplify it for you.
Correct.
As long as you don't hit Control Enter. Now if you hit Control Enter or put a decimal in there, it'll give you the decimal version, that's totally fine as well. C, what proportion of the sampled individuals? I just want to point this out because this one threw a lot of people off. It says of the sampled individuals.
Yeah, I know.
So that's everybody. That is not a conditional, which is what some of us wanted to make it. That is everybody in the club. Yes, Elwin? Yes, right there. Yep. Okay. So we're teachers and, oh by the way, what type of relative frequency is this one? Since I had to go to the margins?
That's conditional.
That's a joint right?
No, sorry, the last one, B. The one that I had to go to the margins for, marginal relative frequency.
Marginal.
Remember,
it's the only thing I know.
remember, hey, listen. We have two variables, number of days absent and roll. When I look at this question, how many of those variables did I actually look at?
2.
For B?
Oh, 4. Wait.
Did I care at all about the roll?
No.
So I only looked at how many variables?
1.
One. When you're only looking at one variable as in B, again, remember I'm looking at B right now. If I'm only looking at one variable as in B, that's when I have to go to the margins and look at a marginal relative frequency. In C, I am looking at everybody, but I'm looking where I have both teachers and 5 or fewer absences. What am I going to call this relative frequency?
That's a.
That's joint. It's where they're both, where they join together. Okay? Notice it's 5 or less. So I'm looking at this and I'm looking to see where it intersects with teacher, which is right here. So 96 out of 700?
700.
Correct.
I don't remember what that simplifies to, but I don't need it. I can just leave it like that.
5 over 7.
Yes, Madeline. Yeah. The sum, the addition, not typically, no. D, what proportion of the students had 6 plus absences? Notice, am I looking at all students again or all individuals?
No.
No, I'm only looking at which individuals?
Student.
Only looking at the students. So I'm not looking at all 700 anymore. I'm only looking at how many? Okay, so what am I gonna, oh, by the way, this was a joint relative frequency.
Oh,
This one, where I'm only looking at students, I don't care about everyone, only students, so there's going to be a conditional, right? The condition is they have to be a what first? A student, yeah. The condition is the students. So what is the answer to the proportion of the students who had 6 plus absences? 46 out of 600.
46 out of 600.
Thank you so much. Crushed it there, Star. Thank you. All right, 46 out of 600. Okay? Now over here, E, what proportion of the teachers? Do I care about everybody this time?
No, just the teachers.
Just the teachers, right? So this is a condition. I'm only looking at teachers. And it was 4 out of 100.
I would, this
I
is
forgot to simplify.
how do you identify if it's conditional?
That's my point here. What proportion of everybody, sampled individuals, right? That was what C said. D only asks about which people? Students. So if I only care about one subset, if I'm not looking at everybody, I'm only looking at students, conditional. If I'm only looking at the teachers, conditional. If you have to be something first, I have to be a student, I don't look at teachers, then that's a condition. We will actually spend a whole lot more time with conditional relative frequency though, Raina, in the next unit. So stay calm, we're gonna spend a lot more time with conditional to make it make sense. I think it was like 2 lessons, wasn't it? Essentially, yeah.
Oh, like with the starters?
Yeah, not the starters, yeah, it was the,
The free throw?
no, not conditional. Conditional was, it's literally said conditional, it's 5.5 and 5.6, I think.
Oh,
Which you looked at
well,
5.6.
conditional was also like that one that I was looking at.
Was there some in there?
The part 2.
Gotcha. All right, F. Is there an association between the role of the person and the number of days absent? Remember, association means knowing one does what? Helps predict the other. Predicts the other. So when I bring that to, helps predict the other. Bringing that to mind here, when I say, is there an association between the role of the person and the number of days absent? Knowing that someone was a student, weren't they more likely to be absent?
Yes, it is.
Yeah.
So I know some people are saying, hey, it's not, they're almost the same, but were they the same?
No.
And so knowing one of them did help predict the other. So there was an association. So if there is an association, knowing one value helps predict the other. I know they were very, very close. But still, there was an association because knowing someone was a student helped us know that they were more likely to have 6+ absences. Yes, Kenzie?
I kind of answered my own question.
Okay. Good. Yes?
I got a P, but that's a no.
Because of that idea, more than likely you said they were very close, right? Approximately the same?
Oh, yes, yes.
Okay. It was supposed to be a yes, because they're not the same.
If you explained no very well, could you get a P?
Ian, can you answer that question?
Yes, well, they,
What
judging
Ian
on the
just
fact
said he
that
did.
I did get a P and I put no, I would assume yes.
Oh,
I would
yes.
assume yes too.
Oh, yes.
Well, yes.
All right, Ian G, how would a mosaic plot look different? Remember, the mosaic plot is proportional to that explanatory variable. How many more students did we have than teachers? 6 times more. So what would the width be for the mosaic plot? For students, it would be 6 times as wide. Or it would be 6/7 of the width, either one that you want to say. So 6 times as wide. Oh, I hate it. All right, moving on then.
Wait, Mr. Kenny.
Sir,
I think a mosaic plot would take into account that there are
correct.
6 times more students than teachers.
So it would be 6 times as wide.
Yeah, but I got a P.
Because you didn't say it would be 6 times as wide. You hinted at it, but did you actually say the mosaic plot for students would be 6 times as wide?
You did
I said that would be
Stop.
very appropriate.
No, you're fine.
Okay.
All right,
You're double wide.
so, gotta go quickly through this. We got 4.5 minutes. Which model is more appropriate for this data? First off, they're both scatter plots are pretty scattered. Can we agree to that?
Yeah.
So then what helps us tell the difference?
So R.
Not the R
Squared.
squared. It's not given R. What do we want for our R squared? High or low? High. So which model was better? B. They had the same amount of scatter, guys. They were both appropriately scattered. But B had a higher R squared.
Coefficient of
Determination.
determination.
Yep. Yes, Phoebe.
Wouldn't A have like a high leverage?
Maybe, but I mean, I can see why you're thinking that, but I wouldn't sweat that detail.
Oh, I also said high leverage.
Yeah, I can see why you're thinking that, but that's just because of the transformation that was applied. But the bigger thing, I mean, did you say B?
Yeah.
Okay. It was more because of the R squared though. The data was fairly scattered around that point. Yes?
I thought Model A had a pattern because most of the data was clustered to the one.
But remember, pattern means that there's a pattern around the residual line, or that line in the middle. There's not a pattern around this line. Because like if you look right here and just focus right there, it is scattered right there. It just has one point that's far away. So you could say it is a high leverage, but that's not it. Yes, Ian?
Model B, because the R squared is higher, which indicates that the
You already read
variation
it.
of the tree species is better explained by the regression line.
Fantastic. What'd you
No, I
get?
got a P.
You made a typo.
I should have put that.
Trees I need to look at that again. There's an issue in there. It's okay, we'll talk about it. Alright, Kinsey.
Sorry, can you explain why Model B was, again, I know because it had a higher R squared, but what does that mean?
So remember, your coefficient of determination is higher, right? So that's the percent of variability in the response variable that's explained by the linear relationship with the explanatory. So like that just has a higher amount of that variability that's explained. Okay, write the equation of the least squares regression line. Ooh, guys, y'all hurt me on this one.
I'm sorry.
So what was the, first off, I need us to recognize basal area has to be the input.
Yeah,
It has to be the explanatory, because this is the coefficient of that basal area. So what was that, negative 0.118?
Yes.
Okay, times basal area.
Oops.
Okay? And then what was the y-intercept? 2 point something?
2.388.
And so what was being predicted?
The log
log
numbers,
of
tree species, predicted log of tree species.
Okay. We need to recognize, and I think they even talked about what was being predicted earlier, didn't they?
Yeah.
Right? Predicting the number of tree species from the basal area. So there's my prediction. There's the basal area. But, and it says here, B, we only took the log number of tree species. Yes, Madeline. You didn't have to, but if you said y hat next, you did have to define your variables. So guys, if you use just y hat next, you do have to define those variables. Bell's about to ring, but last thing really quickly. Calculate and interpret the correlation. R squared is 0.798.
So you
Square root.
Right.
So R is
893.
0.893, but remember, it could be a positive or negative. How do we decide which it is?
Because the
What was-
slope is negative.
Guys, the slope was negative.
Bro.
You've got to pay attention to that detail.
I'm sorry.
So the R is negative. And so be careful. Hold on one last second. Remember, this means the linear relationship between, and put your context,
Strong negative linear relationship.
between, now remember, by specifically interpreting R, you're already talking about the linear relationship. So the linear relationship between context is strong and negative. We should pay attention to our slope there. So that linear relationship between those two things is strong and negative. Head on to lunch. When we come back, we're going to start probability. If you need to ask a question quickly right now, let me know. What's up in the class? Does anyone have like $20?
I do in my car, Emerson.
I think it was my test. The year one test. I didn't put it So remember, I need to get feedback on y'all's test, the test script you turned in, and then we can retest later this week.
I didn't know.
She was like, what's so bad?
The unit 2 test? Yes. Yes, we'll do a retest, but let me get you feedback on your test script.
God forbid I know people. God forbid I know people.
Which she has this morning. I don't know.
So yeah, be careful. That's coefficient of determination, not
And she was
correlation.
flipping.
Does that make
I
sense?
thought,
And literally, they labeled it for you. You said R squared. You killed me on that one. Here it says R squared. Is that? Does that make sense? I got you. Oh yeah. Just be careful. Correlation coefficient is just one.
I'm always so scared that
It's
like
more
microwaves are like
appropriate
blowing
for
up on me.
this data because the.
You ordered a plastic bag.
Oh, again, you called it correlation. That's R squared. Coefficient.
Don't do that, guys.
determination
Don't warm it up
is
in a
higher.
plastic bag. Holy heck, bro.
Like that, and like,
Why am I
yeah,
so
you were
dumb?
almost
What
perfect
is
on
that?
You just said, called it
This
a
is a polar
correlation and
fish.
not a coefficient of determination. If you had found the correlation, you would have been fine there. Okay. I'll go ahead and say this. I think that I'm missing a sheet that I'll have to print out and give to y'all later. We'll figure it out. So this is the next unit, okay? This is our probability stuff. I would put my proficiency scale and prayer model in front. I will make a note quickly that if you remember, I mentioned it before class or before lunch that I'm going to split this unit in two. So you have two proficiency scales. We will only be using one of them. For this half of the unit, we'll test, and then we'll do the second half of the unit. So that should make things a little bit easier to access. And for those who are like, man, Mr. Kinney, I really want some traditional math. This is going to be a little bit mathier. But we also are going to break it down so that if you don't love traditional math, you can still access it pretty well. This is all, I don't have time for this. I think I forgot to actually put, no, I got it right here. No, can't take my time. Okay, so this is the proficiency scale for today. We have actually covered a good chunk of probability with the first lesson and talked about some things. So when you look at this foundational piece, what are some, actually not as much as I was thinking, what are some terms that you have seen before?
Venn diagram.
Okay, so Venn diagram. Joint probability probably connects to what that we've already talked about? Joint relative frequencies, right?
Intersection.
Say again?
Intersection.
Intersections. We will be talking about that for sure.
Outcome.
That someone already said that. Any other things?
Random process.
What do you think the law of large numbers
All
means?
I did was I heard about it.
I
Okay.
feel like if it's large, you need to subtract it.
No.
Union.
Okay. We're going to talk about law of large numbers heavily today. Huh?
Union. Star.
Unions. What do we mean by unions?
Union. This. What do you call that? Together.
So I think you're talking about the intersection actually, which is why we need to break down what a union versus an intersection is. A lot of times people get that mixed up. So you're thinking about the symbols there. Got it? Huh? We did do it in. Oh, you did do some of it in Algebra 2? Fantastic. But we will be focusing today on simulations. I'm surprised no one said anything about a random process.
I did. I was going to, but I was
Yeah, random process. We're going to talk about outcomes and events and simulation, different types of probability today. So, I'm trying to remember, no, we're not getting to any of this target. We're just focusing on the top of this foundational piece. So this foundational piece is based heavily on, hopefully, stuff you did in Algebra 1 with probability, or maybe you did do some in Algebra 2. You sure you did in Algebra 2? Because I think Miss Williams did this in Algebra 1.
Yeah.
Miss Williams, we do it. Miss
Williams is
Williams.
As well?
Yeah, we did take a pre-test on there.
Interesting. Okay, so this is the very first lesson, okay? It starts out real nice and easy, okay? We've got, I just want you to tackle numbers 1 through 3, talking with your small group, in your own words. What does it mean? So, sorry, Mrs. Gallus, that was the one of the teachers that helped develop mathematics. But Mrs. Gallus was a star basketball player in high school, and I could never put my name in there authentically because I was not a star basketball player. But Ms. Gallus was a star basketball player in high school where she was an impressive 80% free throw shooter. And so I want you to talk with your groups. In your own words, what does it mean to be an 80% free throw shooter? If Mrs. Gallus takes 100 shots, how many do you expect she will make? Is this guaranteed? And then tackle question 3. I do want these responses on vertical surfaces so we can directly compare the responses around the room. So please get up to your vertical surface and let's work through number 3. What you working on there, Emerson? Your stats. Yeah, whoever would I be talking about with that? Okay, so we need to be careful, right? So right here, of all attempted free throws, she makes 80%. It's pretty good. We're going to talk more about why that is true. Number one over here, we have out of 10 shots thrown, you make 8 out of 10 free throw shots. Do you think that's true every time?
Predicted to make.
You're predicted to make? Okay, so why would it be that you are predicted to make 8 out of 10?
Because she has a. Go ahead.
He's not a robot.
Not a robot. So we're gonna define some things a little bit more to make this make more sense. But one thing I want you to hear is this. We have, no, we can talk about that part later. So each free throw has a blank chance to go in. So each free throw has a what chance to go in? 80%, right? So we're going to talk more about what this means in general, but to be an 80% free throw shooter, each time there's an 80% chance of going in. So we expect her to make, now I will say, it would not be a percent, how many? We all said we would expect her to make how many? 80, okay? However, we say it's not guaranteed. Why not? Variability, she's not a robot. Probability. Does anyone know a term though for that variability that we've studied before?
Oh, randomization.
Bro.
What?
Kind of. Dang, how did y'all get all the way over here?
Oh,
Kinsey.
bias.
Kinsey.
Bias?
Sampling variability.
I was right. I said variability. I said bias.
I asked which type of variability. It would not be bias though. Okay? It is sampling variability. Okay? Remember, different samples are going to produce different results, right? Okay? So then the next question, okay, so I'm going to come up with this is, pull it up here. There we go. If Miss Gallus takes 100 shots, do you think she will have a streak where she makes 10 in a row? Possibly, but for the most part, what are we thinking?
No, wait. We said yes.
I would say, is there a chance? Yeah.
Oh, the possibly.
Possibly. So like if we're doing 100 shots and she makes 80% of them, on average, out of every 10, notice I said on average, out of every 10, we expect her to make how many?
8.
Say 8. Is it possible though that she hits say 12 in a row and then goes on a string of misses?
Yes.
Because of what?
Variability.
All we know is each free throw has what chance to go in?
8 out of 10.
80%, 8 out of 10. So here's what I want you to do at this point. We're going to go to an applet. Go to statsmedic.com/applets, one person per group, because I want us to talk as a group.
Ah, my bad.
Okay? So one person per group, grab your iPad.
Why do you have your shoes off?
Right?
It smells like.
Not really.
I started the fact. It smells like a wood.
What?
I started the food like.
What does that smell like, Star?
It smells like up ugly.
Okay? Hey, instead of
iPad.
statsmedic.com/applets. I need one person going to statsmedic.com/applets, scrolling down to activities, and we're going to go to is Mrs. Gallus a good free throw shooter? Okay, so is Mrs. Gallus a good free throw shooter?
Now what?
So you'll click on do this. Let's do.
Activities independent?
Let's see. I got a class code for y'all. I've never done it this way before. What does it say? A0.
A03. No, A031 CB.
What paper?
A031 CB. Okay, when you go to StatsMedic, go to that code right there. For it's the third part.
Is that a one?
What the walkie slash?
A03.
So you've got 5 minutes to run this data, and so we're going to shoot.
No.
Make a shot. Make a shot.
Hey.
All right.
Airball.
Oh.
One second.
Hey.
Hooray.
Wait, why should I?
All right.
She kind of
So-
a bucket.
Wait, we did that?
Hey, out of 10, how many did she make? 80%, that's awesome, right?
Yay.
She's a bucket.
I'm gonna get her,
Oh
I'm
my
still at
god,
80%.
Whoa, how'd you do
mine
that?
sucks.
I'm good.
Are we putting us in? Yeah.
No, it's because there's a mathematical reason why this is correct. So like in the
Oh my
sense
gosh.
Ian, oh my
Ian.
god. Chemistry, can you?
Hold on. Oh no, it restarted.
Ooh.
No.
100%. Math is a lot.
Alright, so I will point out this time, I have shot 10 shots, and I made 100% of them. Oh no, right? So what I want y'all to do is I want us to collect data as a class. Now, you'll notice, oh, I don't like this.
Did you download a hack site?
No. It's not showing what I want it to. Hold on.
Is that a 0 and a 1 or an L and an I?
It's 0.
Let's stop.
Well, that's a bummer.
Oh, there's a B.
They changed the
Hey,
app.
what's the class code, chat?
AO3,
Right there.
1 CB,
AO3.
1 CB.
Wait, is that, is that a O or a 0?
It's a 0. Oh wait, I can say O.
Oh, man.
Is that an L or a 1?
A 1.
I got bad news. I'm gonna have to restart this.
Is that a C?
It's a C star.
And is that one a, is that a B?
That's a B star.
It's a D, but it's. Yay! It doesn't matter. You're gonna have to restart over and enter this code. Sorry, guys.
Chat,
Well, I didn't write something down, and apparently I needed it.
1 C C.
Oh gosh.
Those like seeds.
All right. It does, kind of. All right. So what I need you to do is I need you, okay, to go through this, and so after each of these number of shots, to record how many makes or misses you have, right? And then the percent that you've made at that point. So you're going to have to go through 100 data points or shots and then stop periodically at each of those numbers, okay? So what I get, no, just do it as a whole group. It's not going to give me exactly what I want because they took away something. It's a bummer.
Wait, we have a new class code?
Yes, sorry, put in this new class code.
Why my Wi-Fi not working?
I don't know.
Yeah, I'll get you.
Okay.
Okay.
We're just gonna do it like we already.
Well, like, you're gonna do it,
Stop at the number.
so each of us don't have to do it, we're gonna do it all. Yeah.
Alright. So you're going to have to just keep shooting and you're going to record your data values. Okay? Through 1, 2, 3, 4. If you need to restart, you can, but be careful, make sure everyone's engaging. Shoot your basketball. Okay? Oops, sorry. Alright, collect your data. You got 5 minutes. Hopefully it does not take that
It's
long.
not loading.
Grab a different iPad then. So surely someone has it.
I got you guys, I got you.
Thank you.
100%.
Make sure we're recording because
Wait, do we put
I see you shooting and you have out of 5, but did we record 1, 2, 3, 4?
Oh, Mr. Captain.
What are you doing in our heads?
Yeah. So maybe.
Are we on the third one?
Yes.
All the.
Yeah.
Are you doing the check
Just
mark?
gotta
Which
estimate
first
it
was
anyway, I
like
guess.
100? Okay. Shot 2.
No, we can do the
Yeah. We have 3 out of 5, so just put your 3 made. So guys, let's put how many we've made in there. And yeah, just start there at 5.
Well, so 101, then 101.
Code does not exist.
Now, one thing
Oh, like just
at this
put
point
the
is,
first
Bruh.
so at this point, you're gonna have to
So
just
do I
indicate how
do
many
it?
have been made. So just indicate, so made, so just put 5 made here, and then when you get to 10, how many you've made. And then change it to a percent. Does that make sense? So you've made all 5.
We're making a
And then
I got
100%,
it, I
yeah.
got it. Baby, here.
Mathematic uses. You got the right idea still with what you've been doing. So when you created your graph, does it look something like this, where it's very clearly not hitting 80%?
Okay, we had to do the graph.
Yeah, so start to put your data on that graph for me.
Okay.
Yeah, or you could sketch this graph if you want.
So what?
Notice, she's supposed to be what percentage free throw shooter?
80%.
80%, is that where she is right now?
No.
No. She's at 73%? Alright, I'm going to start speeding this up. So down the bottom left, I got quickly take 50 shots. Okay, so what do we notice now about that probability?
It hugs 80.
It's getting closer to 80%, right? Now, how many shots have I taken at this point?
80.
80? Took another 50 just now? Notice it's not quite as close to 80%, is it?
No.
Okay, closer or further away now?
Closer.
Closer? What about now?
Closer.
It's
A
slower.
little bit further away that time.
Closer.
Closer.
Closer. Closer.
So, notice, is 80% true even for, say, 1,000 shots?
No.
No. So what does that 80% really mean?
It's an approximate percentage.
80% is right.
Estimation.
It's the average.
I want to do that so bad.
It's the average. Man, I gotta keep shooting a lot.
It's like their like residual.
I'm trying to get it up to 80%. She's supposed to be an 80% free throw
It's
shooter.
not possible.
Well, it says it up here that she's an 80%. So why is it not 80% on mine so far?
Because we can never truly be perfect. Oh, because we're a computer.
Hey guys, keep looking at that percentage.
It's a computer.
But keep looking at that percentage.
Oh, because we're adding the same amount each time, so you're never gonna get.
Look at that percentage. Has it gotten closer or further from 80%?
It's getting
It's getting
closer.
closer. What's happening now?
It can't get more than 79.9. What?
Is it getting closer or further from 80%?
It's staying the same.
Staying the same? Oh, it's not. Oh, yeah, it is. Up a little bit further. So let me ask you this. Do you think it will eventually get to 80%?
Yeah.
If you do infinite shots,
If we do enough shots, yes.
if you do infinite shots.
If we do an infinite number of shots. So I need us to recognize this right here. In the short term, were we an 80% free throw shooter?
Yes.
I mean,
Yeah.
early on, were we 80%?
No.
At one point, we were a 0% free throw shooter. Even through here, hey, look right here. This line is my 80%. Right here, we deviated a little bit, didn't we?
Yeah.
But as we've gone longer and longer and longer, what are we getting closer and closer and closer to?
80%.
We're getting closer and closer to 80%. And if I keep taking, let's say, infinitely many shots, what's this going to get closer and closer and closer to? 80%. Anybody know of a term that might describe that idea of like we go to like a ton of trials? What do you
Law of
think?
large numbers.
Oh, law of large
Yes.
numbers. Okay. So if we take, Charlie, how many trials did you say?
Infinite amount.
If we take an infinite number of trials, how many will she make?
80.
That's not the right question. What percent will she make?
She'll make infinite.
She'll make 80%.
If you
So-
infinite and the infinite is right.
It doesn't need to be perfect. You can take the data that you have here and graph it, but it would look something, that's not good at all, but might come above and then drop back down. But what's it going to approach? 80%. So what do you notice in the graph? As the number of shots increases, what happens?
It gets closer to 80.
What does?
The shots.
Percent of shots.
What was that?
Oh, as
I don't
x
think
reaches
that's-
infinity.
So that is what you call a limit. So if you end up taking calculus, hold on to this idea of a limit. The percent of shots made approaches
The limit doesn't exist.
80%, except it would here. The limit would be 80%. So in the long run, so for any of y'all that collected this data, did anyone have exactly 80 shots made out of 100?
No.
We did it one.
I had 88. It had 88.
But out of 100 shots, did you ever have 80 out of 100?
No.
You got 81 out of 100? So, in 100 shots, did anybody have exactly 80 free throws?
No.
None for us, right? Why not?
Because variability.
Sampling variability. In the short term. When we're talking about probability, y'all good over there? Do I need to just start sitting star away from everybody?
Oh my god.
It's not me.
It just always is surrounded by you, so.
I'm just a funny guy.
Now let's see if Jess sounds like a
I agree with Charlie.
Stop trying to dog my team.
What do you say?
Okay, so none. Sampling variability in the short term, right? That percentage, right? We typically think 80%, and so 80% out of 10 or 80% out of 100. This is where the common idea of, oh, I'm due for the next one, right? I'm an 80% free throw shooter, so I've missed 2, so I'm due to make the next one. So I'm only going to miss 2 out of every 10. You can't think like that. Each shot is 80% chance of making it in. Each shot is 80%, because in the long run, we have her making what percent of free throws? 80%. Now I want to pause, and I do want to point this out, because I don't think that mathematic talks about this at all, but this is important. Classically, the probability would not even be 80%. The probability that Mrs. Gallus makes a free throw, and this is actually how we note that, makes a free throw. This is known as probability notation, right? It's a lot like function notation. So the probability of this thing happening, classically, is only 50%, or 0.5. Anybody know why I'm saying that classically the probability is only 50%?
Because there's only 2 outcomes.
There's only 2 outcomes. Either she makes it or she doesn't, right? So from a classical definition, right, when we talk about a die, what's the probability of getting a 1?
2.
1 out of 6, right?
Oh, I thought you meant die is a 2.
If you have 1 die, roll that die, the probability of getting a 1 is 1 out of 6.
I was thinking die like 2, like dice after, right?
Oh, no, a die. Die is singular, dice is plural. Yes, Jonathan.
That doesn't make sense. I mean, for 2 wouldn't be an equal chance to live.
And that's correct, and that's what I'm about to talk about, right? So classically, this is when things have an equal chance of happening. So, not things, let's say events. Oh yeah, events have an equal chance. So an event is just what can happen as a result, right? It's also called an outcome. Okay, so there's outcomes of success. Well, actually, no. Outcomes includes multiple events. But an event is just what could possibly happen for a single variable, right? So we would do a classical definition when events have an equal chance of happening. Same thing with if I ask you, hey, what is the probability that an airplane is on time? Classically, the probability that an airplane is on time is what? 50%, yes or no, right? It is on time or it's not. But that doesn't make sense in the real world. So in the real world and in statistics, we don't do classical definitions because events don't have an equally likely chance. So how do we calculate a probability? The probability of an event is equal to what? How do we determine the probability of her making those free throws? By a percentage, but how do we determine that percentage?
Out. How many did she make it?
Okay.
Was it in on?
So the likelihood or the number that she made it, so that's the number of successes, right? So it's the, let's actually say the frequency of successes divided by the what?
Number of attempts.
Okay, so total trials. So it's frequency of success divided by how many total trials there are. But this is also why it's important. Can we only look in the short term? That percentage is always in the long run. This is known as a relative frequency definition of probability. And only looks at the long run. You'll hear me say a lot, and you'll see it in mathematics, after many, many trials. Okay? So that's a big thing to hold on to there. And that really should go under number 9, I should say.
Mr. House, what, I'm sorry, I'm so sorry, Mr. Hayes. I'm so sorry, I'm so sorry, Mr. So what, I'm so sorry.
Yeah? I don't.
In the after relative frequency, what did you simplify?
What?
In the definition?
Oh, definition, yeah.
Oh, okay.
I got you. As many, many trials. So this is how we would interpret that. In many, many trials, Mrs. Gallus does what?
Eventually makes 80% of her shots.
80% of her
Shots.
free throws.
Oh, my bad.
Just because we're specifically talking about free throws, not just any old shot, right?
So yes, sir. Is it in or
There
after?
is an R right there.
Free. Is it in or after trials?
In many, many trials, Mrs. Gallus makes 80%. So this is known as a long run relative frequency. So please understand, especially in statistics, we don't use a classical definition of probability because a long run relative frequency will approach that classical definition if you do many, many trials. Right? So if I did infinitely many rolls of a die, single die, what percentage of them or what fraction of them will be 2s?
I don't know.
Wait, what, can you repeat the question?
If I take a single die and I roll it infinitely many times, what fraction of those die will show a 2?
2 out of 6.
One
One out of 6.
1 out of 6. 1 out of 6, right? It's only a 2. So it's 1 outcome of success divided by 6 total outcomes. Notice the long run relative frequency will approach that classical probability if we do it many, many times. Okay? Oh, I did not put, oh, I need to fix that. Okay. So when we talk about probability, right? Right. Does anyone know what numbers the probability has to fall in between?
0 and 1.
Okay? Has to be between 0, which means what about the likelihood of that event?
0 means not likely.
Not likely, impossible. If the probability is 0, it cannot happen.
No.
So it has to be between 0 and 1, which means
Always happens.
always happens, guaranteed to happen. And please don't write this big because we got a few more bullet points.
Oh.
Okay? Cannot happen, guaranteed to happen. Okay?
Can't happen. Wait, one must happen.
Guaranteed to happen. A probability of 1 is guaranteed to happen. Short term is very what?
Very short.
It's not
Not as many days.
less accurate.
Less accurate because it is unpredictable. Unpredictable, imprecise, but more because it's unpredictable. What's causing it to be unpredictable?
Variability, sampling variability.
Sampling variability, right? But in the long term, what is it? Long term it is
Predictable.
predictable. Right? Short term it's unpredictable. Long term, what's it going to be? Predictable,
Guaranteed.
right?
Bruh.
Say that one more time.
Guaranteed.
Not guaranteed, because what is there still? Sampling variability. Remember, did I actually ever get up to 80%? No. Would I eventually? Yes, but remember we said we have to do how many shots?
A lot.
Infinitely many, right? So I can't get to infinitely many shots, but I mean I can look in the long term and know approximately what it is. And so this is the long run relative frequency. So long run relative frequency is how we define probability. Okay. Andrew. Okay. All right. We got 3 minutes. We got to get through this. Law of large numbers. Okay. So does anyone know what we just ran in the calculator? It was a simulation, right? We didn't actually have her shoot free throws, did we?
Unfortunately.
Not unfortunately, we didn't. But we had the computer generate what it could look like, right? Okay, so we did a simulation. So simulated situations, let's say simulated relative frequencies. Relative frequencies. What are they going to do? What are those simulations going to help us do? Predict. By the way, when we say relative frequencies, we mean probability. So they're going to help us predict, or let's say it this way, are going to approach what?
One.
Approaching exponential.
Well, what is it going to approach though?
The predicted.
The true, the classical probability, if it's equal events, right, or equally likely events, but the simulated relative frequencies are going to approach the true probability when?
At the number of, as the trial, number of trials
Infinity.
increases.
So in many trials. Why we came up with that language, I don't know. Really, infinitely many trials. But many trials, mostly because infinitely many is not really possible. Okay? So, long run relative frequency, like the law of large numbers. If we keep simulating over and over and over again, what are we going to approach? The true probability. And we saw that. As we got to 20,000 trials, did we get closer and closer to 80%?
Well, yeah.
Yeah, 100%. Charlie, you had a question?
Did we ever get about like a number 3 and number 8?
We did talk about 3. We kind of skipped over 8. Don't stress 8. These are the big ideas. Tomorrow is your test. It is just on the bivariate data. If you have questions while studying, please shoot me an email. But, and I'll be more than happy to respond. Do not forget, focus on concepts first. You got to know your terms, you got to know your definitions, and then, huh? I already passed it back.
Are we doing one?
No, you do them before the DYUs, and I give it back to you before the test. If you have, hey, you need to fill this section out a lot, then you need to add some more to it and return it back in.
Are you targeting someone?
Huh?
Are you targeting someone?
No, not you, Star. Definitely not you.
Wait,
Or people who haven't turned it in at all.
I'm seeing that on my paper, actually.
But please make sure that you are finishing out your Frere model, add some things, focus on concepts, ideas, and practice putting it into play.
I bet I can hit 80% of my free throws.
Yeah, if you haven't done a couple progress checks, you might want to do those to prepare for your test. They might be helpful. Yes. Did you get it back?
I never seen it.
Oh, I gave you that.
At the twilight, last gleaming,